One more thing just to add, guys, keep the questions coming in. Remember that Q&A window at the side of the screen there, just to let us know how we're doing. Please ask any questions you feel that you're interested in.
Yeah. We'll just hop back right to the PowerPoint here real quick just to do a review of some of those things that we talked about. So bringing in the 3D objects is going to be here in your reference model list. You'll be able to see anything that you want, be able to bring it in there. And then you can also create the site layout plans. We're going to get into the cranes next. I'll bring that into the model. But any reference objects that you have, any of the different cranes, you'll be able to create these drawings, add in the dimensions, the radius, marks from the actual trucks and so forth. So you'll be able to submit that as a legitimate piece of your project there. And then, of course, being able to share this, those reference objects will transfer then over to Tekla BIMsight, depending upon the format, along with all of the other intelligent information within the model, the UDAs, RFIs, and so forth. And they'll also be able to see these points that you add into the model. So whatever you put in there, they'll be able to then see that, and you can coordinate that and communicate back and forth between the two. Just to highlight a couple of the advantages of using Tekla BIMsight on a project and using an actual model is that you do have the ability to attach documents to objects within the model. RFIs, Excel reports, Word documents, PDFs for the actual drawings that can all be linked there. This thing right here for exporting IFC property sets is that when you create UDAs or tag something with a UDA in the model, information is written to that object. You can then control what of that information is then wrapped up into the IFC export and then linked to these objects. So if you had your own custom IMP file or your custom UDAs, that would be linked to these objects as you set it up through the property sets there, which obviously is a huge advantage. You can then also run a clash detection within Tekla BIMsight, so that you can do that earlier and more often during the project life cycle. You don't have to wait for one person who has a specific license of the software to run this. You can do it yourself. The change management is real easy. If you just had this phase 1 modeled in, and then the detailer sent you the other phases and so forth, you don't want to lose any of these documents or things that you have linked to those pieces. So we have a relink function where you would just reload the IFC file and it'll link everything to those individual objects so that you can continue to build off what you've already done, but still have the latest and greatest version of the model. You can also save views down at the bottom for quicker navigation to highlight specific things. And then ultimately the last thing, again, this is free. So there's really, with this free software, there's really no reason why 3D models shouldn't be used on every project.
Yeah, I mean, just to highlight, I mean, we always talk about this buzzword BIM, building information modeling, and this to me is really what it's all about. We can talk about interoperability of programs all day, and the fact that we can transfer one model downstream to another platform, for example, but the whole idea of building information modeling is the data behind the 3D model, and that's what this is all about. If you've got some shareable tool with all of these properties, all of this information, change management, RFIs, drawings, you name it, all behind the real model objects, then you have a building information model. And I think Lee's going to talk a little bit more about even more power beyond that.
Yeah, even going down further, when you get into the facilities management, is that with the building information model, with this Tekla BIMsight, you can actually hand over to them, you can link test certificates for steel sections, like CVN testing, any weld information, the actual paint specs that were used can be all linked to that. Hardware information can be linked to objects in the model. For example, like this little system here, if you didn't know, the sprinkler, smoke detector, whatever it is, if you wanted the user's manual attached to it or the HVAC, you could have that all linked in the model, so that instead of handing over boxes and boxes of drawings, you would hand over a model where they could actually see what's behind each wall with the associated documents linked to it. Again, like another bullet point down here, the maintenance manual linked to the HVAC. really just handing over one file to be able to do that, and people actually are doing that on projects right now.
Yeah, I mean, to give you like an example of one obvious benefit of this, like putting facilities management into a building information model, or facilities management information. A guy from Texas was telling me one time about this job that they did for a school, and they had a lot of things like HVAC plant and stuff like that up in the ceiling of the classrooms. Now, when something fails, the custodial staff, the janitor, whoever it happens to be, has to go and disturb the classroom, get a ladder, climb up, move the roof panels, do all that stuff while the kids are trying to learn, and basically wasting all that time, whereby he had a building information model, had access to all that information for that, and was able to do that without even walking into the classroom, get the reference number from the sprinkler head or whatever it was that was faulty, and order the new parts so the class didn't have to be disturbed. I thought that was a really good example of a good idea for using facilities management based on a construction model.
Mm-hmm. Yep. And again, using the model further and further downstream. And then again, just to review some of the field surveying and layout information here is that'll be written from the model out on site. This is a picture of the Nomad and some of the equipment that they use there. Tag the information in the model, and also vice versa, bring it back into the model for as built. Maybe they poured a wall that's wasn't perfectly square or whatever. They can snap the points and bring that in. And these are some pictures that I think really depict this well, is that you can see tagging the perimeter of the concrete here, and then how it actually was out on site. So that type of detail, that type of accuracy being used there is this.
As Lee was saying earlier, I call it BIM for the job site, but it's really like using CNC data or using computer-based data rather than a drawing that somebody has to interpret. It's based on data that was in the model and exported out electronically, so it's almost like CNC data for the job site.
Yeah. And again, this is what Ian talked about previously, is that you'll be able to see your position, your location, and where you need to go or what needs to be laid out. To be able to effectively plan all this. And then you can see here on the left, if we didn't include the DXF, it's just a cluster of points all over the place, almost like a connected dots nightmare. But then when you actually bring in the DXF and it's overlaid over something, it brings it all into context and really refines what you're looking at. And this is something Ian will talk more about this, but actually before the project even begins, actually using some of the Trimble equipment to scan the existing surface to then bring into the model and then take out to the field. So adding another element to this.
Yeah, we've been playing around with this point cloud scanning, and that's the device that you see there on the left. It scans a ridiculous, I think it's like 19,000 points per second or something like that, or points per minute, which is really phenomenal, and builds up a 3D picture of anything, any place that it can see. It's some real accurate stuff. Here it's been used just to scan like floor surface analysis, for example, and you can create these maps of like hot and cold areas or high and low spots in the based on the point cloud. Go back one slide, yeah, or back 2 slides now. So that once you've got that, then we're working on ways to get that into the Tekla model, and then use that to lay out any like retrofit structure or anything like that as well. Now we've been highlighting the Nomad with the LM80 software on it as well, but Trimble also has a slightly larger and more robust machine, this FieldLink machine that we showcased at our user group meeting this year. It runs a full Windows 7 system as well, so it's almost like a mini computer, but it's ruggedized, so it's dust proof, it's shock proof, all of that kind of stuff as well, so it gives you again access to model information in the field. So just going over this one as well. This is one example of a use case for the 3D point cloud scanning, where as-built drawings were shown there, brought into a Tekla model and overlaid with laser scan data, so that we could compare what was supposed to be where and what had access and what we could get through the doors in the existing model, and what if we were positioning something somewhere that it wasn't interfering with anything else that was there already.